Hello, this is our project demonstration for project 3. My name is Alvin and I worked on this project with Brian Chen and Ethan Su. So in our project we played around with the BERT language model and ran a bunch of experiments on it. In the in the first few cells we imported all the files into our Google Drive. So all the input files and the code workspace. Here we created a data frame and we printed the first 5 edges of our input file, and then down here we install and import some libraries and BERT models that we use in our project 3. And in this cell we started to set the training batch size and the valid batch size, as well as the learning rate, the number of edges, and the maximum length in each string, as well as the model name. Down here we started to define our data sets, and we use this code to initialize the BERT model input parameters like input ID, attention mask, and token type IDs. Down here we have a training data ratio that we change in our experiments, and then we grab the train data set and the valid data set, which in the training data set with this ratio we get the first 1900 rows of data in our input file, and the valid data set only has the last 100. Here we continue with training, with writing the parameters for our training parameters and our valid parameters. We change the batch sizes to experiment with different sizes. And then down here we import CUDA, and we define the BERT model here by adding different layers to our model and outputting the parameters we mentioned earlier, like input ID, attention mask, and token type IDs. And then down here we create an instance of the model for fine-tuning, and here we defined loss to evaluate the performance of our BERT model by comparing the predicted and expected outputs. We optimized the weights here, and then we set the number of epochs. This is something we changed in our experiment as well. And then finally, or not finally, but near the end, here is a function to fine-tune the model. We pass in the training subset and zero the optimizer gradient forward pass output. We define label and loss here. We backward and optimize, and then we update our loss history. In this cell we fine-tune the model for the nominated number of epochs, and we plotted the training loss on our graph, where y is the training loss and x is the number of steps. And then in the last cell we looked at the validation subset and we passed it into the model, and we finally use this cell to output our score. So if I run this, it should it will output the validation scores for um, these different scores metrics. So we connect to GPU, and then if we run all the cells, it will work. While this is running, we also did we also recorded our experiments. So we took some parameters like batch sizes, learning rates, valid batch size, training data ratio. Um, we also took the batch size for training parameters, the batch size for valid parameters, and the epochs. And we ran a bunch of experiments with each different input, and we plotted the different metric scores on the graphs. So here we have learning rate, train batch size, valid batch size, training data ratio, and batch size for training parameters, batch size for valid parameters, and epochs. And after carefully analyzing the tables, we found the most accurate input for each table. So that so here we can see the most accurate learning rate was 1 e to the negative fourth. The most accurate valid batch size was 128. Training batch size was 32. Training data ratio was 0.95. Both batch size for training parameters and valid parameters were 64. And finally, the epochs most accurate was 4. And we took all of these accurate uh, input parameters and we put it into this BERT model, which is still running, but it will eventually output the metrics soon. So here we can see the validation finished, and we have our scores for each of the metrics here. And this is the end of our experiment for project 3, where we just played around with the BERT model. We tried different parameters, changed a few of the variables, and tried to find the most accurate ones. Thank you.